Have you ever wondered why reactor explosions happen and the consequences they leave behind? Imagine, if you will, an intricate dance of particles, a ballet of atoms splitting and recombining. This is the heart of a nuclear reactor, a place where energy is born from the very fabric of matter. But sometimes, this dance spins out of control, leading to a reactor explosion. These explosions are not mere accidents. They are a culmination of various factors, including design flaws, human error, and sometimes sheer bad luck. And the aftermath? It's a chilling reminder of the destructive potential of our own creations. We're talking about not only immediate devastation, but also long-term impacts on the environment and human health. Understanding these incidents is crucial to preventing them in the future. It's a sobering lesson in responsibility, a call to respect the power we wield. In the next few minutes, we will embark on a journey through time to explore some of the major reactor explosions. The first major reactor explosion occurred in the United States in 1961. This incident took place at the Stationary Low-Power Reactor No. 1, or SL-1 for short, which was a military test reactor located in Idaho. Now let's delve into the details of what happened. The SL-1 reactor was undergoing maintenance on a cold January night when something went terribly wrong. A sudden surge in reactivity caused a steam explosion which led to a partial meltdown of the reactor core. This explosion instantly killed the 3 maintenance workers present at the site. So what caused this surge in reactivity? It was traced back to a single control rod which was manually pulled out too far. This caused a prompt criticality, a rapid increase in power that the reactor's cooling system couldn't handle, leading to the explosion. The SL-1 explosion was catastrophic, not just because of the loss of life, but also due to its environmental impact. Radioactive material was released into the atmosphere, contaminating the surrounding area. Thankfully, the reactor's location in a remote part of the Idaho desert meant that the fallout was limited to a relatively small area. Now let's talk about the aftermath. The SL-1 incident served as a wake-up call to the nuclear industry, prompting significant changes in safety procedures and design. For instance, reactors were redesigned to prevent a single operator error from causing a catastrophic accident. The incident also highlighted the need for enhanced training and stricter regulations for reactor operators. In a way, the SL-1 explosion served as a harsh lesson in the early days of nuclear power. It reminded us that while nuclear energy has the potential to provide vast amounts of clean power, it also carries inherent risks that must be managed with utmost caution. It underscored the importance of safety protocols, operator training, and reactor design in preventing such incidents. The SL-1 reactor explosion was the first eye-opener to the potential dangers of nuclear power. It set the stage for a more safety-oriented and regulated nuclear industry, shaping the way we handle nuclear power today. The next major incident occurred in 1979 at 3 Mile Island. Let's set the stage. Picture this. It's the wee hours of March 28, 1979, in the tranquil heart of Pennsylvania. The 3 Mile Island nuclear generating station with its twin reactors is humming along when suddenly, a cooling malfunction leads to a partial meltdown in one of the reactors. What exactly happened, you ask? Well, a combination of equipment malfunctions, design-related problems, and operator errors led to the catastrophe. The reactor's cooling system malfunctioned, causing the core to overheat. This resulted in the melting of around half of the reactor's fuel, but thankfully, the containment building held up, preventing a full-scale disaster. The immediate aftermath was a whirlwind of panic and uncertainty. Thousands of residents were evacuated, fearing exposure to harmful radiation. However, the actual radiation released was relatively small, and no immediate deaths or injuries were reported. Yet, the psychological impact was profound and far-reaching, breeding a deep-seated fear and mistrust of nuclear energy in the hearts of the American public. The long-term environmental effects were surprisingly minimal, thanks to the containment building's resilience. But the incident was a wake-up call, highlighting the potential dangers of nuclear power if not managed correctly. So, what came out of this catastrophe? The 3 Mile Island incident led to sweeping changes in nuclear safety regulation. The Nuclear Regulatory Commission ramped up its oversight, requiring plants to enhance their safety systems and procedures. It also prompted the industry to establish the Institute of Nuclear Power Operations to promote safety and excellence in operations. The incident also sparked a halt in the construction of new nuclear plants in the United States, a trend that lasted for several decades. It was a clear signal that the stakes were too high to take lightly, and it forever changed the way we approach nuclear safety. The 3 Mile Island incident was a turning point in nuclear safety regulation. It served as a stark reminder of the potential risks of nuclear power, and it spurred efforts to make nuclear energy safer and more reliable than ever before. But nothing could prepare the world for the disaster that occurred at Chernobyl in 1986. In the early morning hours of April 26, the Chernobyl nuclear power plant in Ukraine experienced an explosion and fire that result in a catastrophic nuclear meltdown. The cause? A flawed reactor design and inadequately trained personnel conducting a late-night safety test. The explosion released more than 400 times the radioactivity of the atomic bomb dropped on Hiroshima. The immediate aftermath was horrifying. 2 plant workers died on the night of the explosion and 28 more succumbed to acute radiation sickness in the following weeks. But the casualty count didn't stop there. The World Health Organization estimates that about 4,000 cases of thyroid cancer reported in children and adolescents who were exposed at the time of the accident are attributed to the Chernobyl disaster. The environmental impact was equally devastating. An area of roughly 2,600 square kilometers, known as the exclusion zone, is still largely uninhabitable due to high radiation levels. Forests, water bodies, and wildlife within the zone continue to show signs of mutation and abnormalities. The international response was immense. The disaster led to an outpouring of humanitarian aid and sparked major changes in international policy on nuclear safety. The International Atomic Energy Agency ramped up its efforts to promote nuclear safety standards and improve the rapid response to nuclear accidents. The Chernobyl disaster had far-reaching implications. It exposed the dangers of nuclear power when not properly managed and highlighted the need for stringent safety measures, rigorous training, and international cooperation. It also led to a wave of anti-nuclear sentiment, prompting a shift towards renewable energy sources in many countries. Despite the disaster, the Chernobyl power plant continued to operate until December 2000. Today, the site and the surrounding exclusion zone serve as a stark reminder of the worst nuclear disaster in history. Chernobyl remains the most devastating reactor explosion in history. In 2011, another major reactor explosion occurred at Fukushima Daiichi. Nestled on Japan's Honshu Island, the Fukushima Daiichi nuclear power plant was thrashed by an unexpected guest, a massive 9.0 magnitude earthquake, followed by a devastating tsunami. The double disaster led to the most significant nuclear incident since Chernobyl. The earthquake and tsunami damaged the plant's cooling systems, causing 3 of the 6 reactors to overheat. The failure of the cooling systems led to meltdowns, hydrogen-air chemical explosions, and the release of radioactive materials into the environment. The immediate aftermath was catastrophic, with the evacuation of over 150,000 residents and the declaration of a 20-kilometer exclusion zone. The long-term effects of this disaster were equally devastating. Radioactive materials found their way into the Pacific Ocean, leading to significant concerns about marine life and the broader ecosystem. The disaster sent shockwaves through the global community, leading many countries to question the safety of nuclear power. The Japanese government and Tokyo Electric Power Company, the plant's operator, faced criticism for their handling of the crisis. Many felt that the response was slow and that vital information was withheld from the public. This led to a loss of public trust in nuclear energy, with several countries opting to phase out their nuclear power programs. The Fukushima Daiichi disaster was a stark reminder of the potential risks of nuclear power, but it also highlighted the importance of preparedness, effective crisis management, and transparent communication. The incident led to a re-evaluation of nuclear safety standards worldwide, with an increased focus on natural disaster preparedness and the safeguarding of nuclear plants against extreme events. The Fukushima Daiichi disaster reminded the world of the ongoing risks of nuclear power. But it also underscored the importance of learning from our mistakes to ensure the safety of our energy future. So, why do reactor explosions happen and where have they happened? The answer lies in the cautionary tales we've explored. From the SL-1 reactor, we learned the devastating consequences of a single criticality excursion. The 3 Mile Island incident underscored the significance of human error and system malfunctions. At Chernobyl, we saw the catastrophic results of flawed reactor designs and poor safety protocols. And the Fukushima Daiichi disaster demonstrated the vulnerability of nuclear facilities to natural disasters. Each of these incidents has left an indelible mark on our history, teaching us valuable lessons about the power and peril of nuclear energy. They've highlighted the need for stringent safety measures, robust designs, and comprehensive disaster management strategies. They've shown us that while nuclear energy holds immense potential for good, it demands our respect and careful stewardship. In the end, the lessons from these reactor explosions are a stark reminder of the balance we must strike between harnessing nuclear power and protecting our planet.